Can you hear me?
Yes.
Hello. Okay, brilliant. I will share my screen now. Okay, are you able to see my screen?
Yes, we can see your screen.
Okay. Thank you very much, everyone, for coming. I will start now. So here, thank you very much for everyone, not only for the attendees, but also for my CAD organizers for this conference. I would like to present our paper on of the systematic literature review of machine learning applications for community-acquired pneumonia. That is part of my PhD project in the University of Leicester. So the outline of this presentation is as follows. I would like to present the objectives of this paper, then a broad description of the disease, and finally going to the literature review methodology, and finally present to you the results. So let's start with the objectives. The aim of the literature review is to create a framework in the field of applications of machine learning for supporting community-acquired pneumonia management. And this, like in the old management process. And the specific objectives of this paper was to create a classification framework for different stages in the disease management, then identify the techniques that have been implemented, how sophisticated have been or what are the gaps for the current techniques that are available, determine state of the art of the field, and finally identify such areas that can be benefit for the research. So now I would like to talk to you a little bit about pneumonia. Pneumonia is a lung condition that is highly related with mortality. Now we have all the COVID-19 situation, which gives us a really good insight about the implications of pneumonia. Some of the consequences of this disease are the high cost for healthcare systems, the capacity problems also for hospitals, and as I said before, is correlated with high mortality. The symptoms, one of the problems with the disease is that the symptoms are quite generic and can be confused with any kind of infection that are associated with fever, production of mucus, and lack of oxygen. And the other problem is that the different causalities of this disease, which could be bacterial, viral, or fungal. In terms of management, we have two steps. The first one is the diagnosis, which is mainly based on X-rays, and second one, the hospitalization. And the hospitalization, basically, it depends on how the severity is determined. So here in this chart, we can see different scores that depends on the symptoms of the patient. And these scores determine the severity, and they are all used in different countries depending on the healthcare and the guidelines for countries. So there is not a consensus on this. And this is quite important because this is an opportunity to machine learning application. So I would like to talk to you about the methodology, because it's quite important since we took the guidelines and the methodology from Peterson et al., which is methodology for systematic reviews in engineering. And we complemented this methodology with the PRISMA checklist, which is highly accepted in the medical field. So here we are joining both sides, the computational and engineering side of machine learning with the clinician applicability. The first step in this methodology was to define the literature review, those that we defined based on a machine learning project, basically. So we focus on the outputs of each study, then identify the data, types and source, the algorithms used, how they compare and assess these algorithms, and finally we wanted to know about the interpretability that different researchers gave to their models. We defined different databases And once in the databases and extracted the study, we define inclusion and exclusion criteria. The main between them are all the studies should belong to peer-reviewed journal or conferences. The studies should get like community-acquired pneumonia as the main disease of study, and we didn't include any COVID-19 study for this purpose. And finally, we extract the main data and the main information from each study, which was data information related to size of the data set, source of the data set, and type of the data, algorithms used, and performance measures. So now I would like to talk about the results. And the first result that we found, even before presenting the studies, was this framework to classify the studies in different steps on community-acquired management. This is diagnosis, outcome prediction, and when we talk about outcome, it could be prediction of severity or mortality of the patient, then ICU admission, whether a patient gets into the ICU or not, and the treatment provided. So now the corpus of our literature review was based on 23 articles that, as you can see in the chart, most of the articles are from recent years, which is an indicator of the problem has taken a lot of interest in the community. And also we identify the main outputs, and most of them in the categories that we define are binary, which is important since this means that the field is still in exploratory stage, and it could improve the way that the output and the problem is seen. And finally, we identified that the main data, the main features used are the data gathered in hospital when admissions, the first moment at admissions in hospitals. Now, I would like to talk about like answering each of the questions. Now, we have the data, and we identified that, as I already said, most of the data was from admission data, but we also identified that images were used, and images are used basically for a diagnosis. The data sets of the studies have different sizes, but most of them are between 1,000 and 20,000 samples, which are decent size of data sets. However, the representation of these data sets depend on the location of each research, plus they have different sources as well depending on this location. This is important because to compare and determine the state of the art was kind of difficult given the difference of the data sets and the populations that they were studying. In terms of algorithms, we can see that most of the algorithms used were relational. And when I say relational, is those machine learning algorithms that provide any type of explanation, from random forest algorithms to KNN and regressions. However, they didn't use too much deep learning or neural networks. Here we can see that we have neural networks as the second most used algorithms, which is contradictory with what I just said. But the thing is that most of these neural networks were used before 2012, which means that they didn't went beyond 3 layers. So they are quite small neural networks, and still open the field to the application of more sophisticated neural networks. The fourth question is about the measurements. So most of the study use arrow curves and accuracy as the determination. The arrow curve is really important for the medicals to interpret the results given the trade-off between the false positive and the true positive. And finally, I would like to mention that most of the study limit the interpretability to the explanation of the model and not to explain how the features interact with the outputs, which is really important in terms of usability in the future. So I would like to mention two specific studies that caught our attention. The first one is Sarisitinov in 2019, not only provide the diagnosis of the disease, but locate the clusters in the lungs in the x-rays. And Prisbilla in 2020 provide a model based on Markov chains to predict how the transition of a patient and determine whether a patient could die or not. Finally, we reach five main conclusions, but I would like only to highlight the gaps in the field that we identified. And the first one is that to our knowledge, there are no actual application in either in the guidelines or in a hospital in the world that use machine learning to support community-acquired pneumonia. The second one is that there is still a lot of path and space to apply really sophisticated machine learning models to different dimensions. It could be either for prediction of severity, treatment, or ICU admission. And now, complementing this gap, I would like to say that treatment is the dimension that has been less addressed in the whole spectrum of our corpus. And this is really important, since in this area could be a really good opportunity to machine learning to help healthcare systems. These are the big vision of our literature review. Here are the references divided by dimension, and that was it. I'm open to any question, and if you want to discuss further, here's my email. I'm more than happy to answer anything or any questions that you have. Thank you very much.
Thank you for the presentation. So if we are having any questions, I would like to ask you one question. What did you discover, if you discovered any research activity on pneumonia or causing from COVID patients?
Can you go deep in that question?
Yes,
not following.
yes. COVID-19, the new disease, has been shown to cause a lot of patients with serious complications, pneumonia. So did you find any research activity, any research studies with COVID-19 pneumonia?
So the thing is that my project was defined before COVID-19. So we left out all the studies on COVID-19. Of course, like in this moment, there are a lot of studies, and you can find a lot of papers talking about COVID-19. However, our study is mostly focused on community-acquired pneumonia, which is another type of pneumonia, and its main cause is bacterial. I mean, it could be any of the other causes, but the main cause is bacterial, but different to COVID-19, which is viral.
Okay, thank you very much.